Hey everybody, Dr. A here, and in this video we are going to be exploring an example of stress transformation. So let's take a look at what we have. We are being asked to determine the equivalent state of stress on the element if it is rotated 60 degrees clockwise, and then we're being asked to sketch the transformed element. So let's go ahead and write solution. And remember, as we always say, you want to write all of the steps down. Don't just watch and listen. You want to take notes on this on a piece of paper in your notebook so you can best understand. So to get started, let's go ahead and make sure we know what we're looking at. Well, if you look at this given element, you have two normal forces. You have 150 psi in the horizontal direction pointing away from the element, which means that 150 psi is going to be sigma x, and it's going to be positive, okay? Positive 150 psi or in tension. In a similar way, you have 100 psi on in the vertical direction, also causing a tensile effect on the element. So you're going to have a sigma sub y, and that is what is the 100 psi. Again, it's positive. You also have a positive shear stress of 75 psi. And if you remember, if you watched the previous video where we talked about the sign convention, what the sign convention says is that if the shear stress on the top horizontal plane is pointing in the positive x direction, or you can think of it as the shear stress on the right vertical plane is pointing in the positive y direction, then that is a positive shear stress. So we're going to say tau xy is 75 psi. And then the question is interested in a 60 degree clockwise rotation. So that means that theta is going to be negative 60 degrees, okay? Because based on our sign convention, we call counterclockwise positive and clockwise negative. So let's go ahead and get started. We're going to go ahead and write our governing equation, sigma x prime comma y prime, which remember is actually two equations balled up to one. So we're going to have sigma x plus sigma y over 2 plus and minus sigma x minus sigma y over 2 times the cosine of 2 theta, and then plus and minus tau xy sine of 2 theta. And remember, this is two equations where sigma x prime represents the terms with positive signs, and then when you have a comma here in your subscript, that indicates you have a second equation, which is sigma y prime, indicating the negative terms here. So let's substitute values in. We're going to say sigma x prime, we're going to do this one at a time, of course, is going to be 150 psi plus 100 psi divided by 2 plus, because we're looking at sigma x prime first, 150 psi minus 100 psi, all divided by 2, times the cosine of 2 times negative 60 degrees. So when you enter into that trig function, that cosine, you need to input negative 60 degrees there. And then I'm going to wrap this around, plus tau xy is 75 psi times the sine of 2 times, again, negative 60 degrees there. So sigma x prime comes out to be 47.5 megapascals. Be very careful when you input this into your calculator. Don't try to be a hero and do it all at once. You can put it in one piece at a time and make sure your calculator setting is in degree mode right there, okay? And in a similar way, we're gonna say sigma y prime is equal to 150 psi plus 100 psi divided by 2. Here for the sigma y prime, we have a negative sign, and then open parentheses 150 psi minus 100 psi, all divided by 2, times the cosine of 2 times negative 60 degrees. And then here we have the minus sign. Again, we're looking at sigma y prime, so that's going to be minus 75 psi times the sine of 2 times negative 60 degrees. Make sure you punch all this into your calculator correctly. You should get sigma y prime of about 202. Oh, did I say megapascals? Watch those units. PSI are our units. So 202 PSI. I don't know why I was thinking in metric, but our given problem was in PSI, right? Yep. All right, and then finally, we need the transformed shear stress, tau x prime y prime, and our governing equation is going to be sigma y minus sigma x, all divided by 2, times the sine of 2 theta, plus tau xy times cosine of 2 theta. And so we substitute our values in. Again, this is one equation. So we're going to have 100 psi minus 150 psi divided by 2 times the sine of 2 theta, which is negative 60 degrees, plus 75 psi times the cosine of 2 times negative 60 degrees. And when you evaluate this single value, your tau x prime y prime should come out to be negative 15.8 psi. All right, now to sketch the transform section, what we do is we can kind of dash in our global coordinates, which looked like this. But remember, we have rotated the element 60 degrees clockwise, okay? So what we are doing here is we are rotating, essentially looking at a rotated axis of 60 degrees clockwise. And when we do that, that's going to generate us our x prime and y prime set of coordinates, okay? And again, that's a right angle right there. And so from this is where we are going to sketch our transformed element with these coordinates, with this coordinate system. So we can sketch on here. Let me draw this a little bit better for us. We can sketch on here our transformed element. And of course, right here, this is our sigma y prime, which is going to be equal to the 202 psi. And on the opposite side, we still have that sigma y prime. And then in the x prime direction, we calculated a sigma x prime of 47.5 psi. And in a similar fashion, it is on the opposite face. So here's sigma x prime. And then we have the shear stresses. I'm going to change colors for that. The shear stresses came out to be negative 15.8 psi. So when we're looking at this rotated set of axes, we're going to have the negative 15. Let me write that a little better. 15.8 psi pointing in the negative direction here. So notice that when we're referencing our y prime axis, this 15.8 psi is pointing away from the positive y prime axis. And because of that, we're going to have it likewise on opposite sides as well. And this is our transformed element. Again, not my best artwork, so maybe take some time and draw this nice and neat on your own paper and make your artwork look better than mine. But this is the final sketched element, and that concludes our example. And again, your answers are your sigma x prime, your sigma y prime, your tau x prime y prime, and then your transformed element are all part of your answer. Thanks for watching. Please hit like and subscribe.